Ready? All right. Let's see. Today we are going to be working on Ardalis.Extensions, open source library for C# extensions. And I like to contribute to it once in a while. I think there's some useful stuff in there. And one thing that I'm thinking of doing today is adding a string extension. So it's in C#. And I noticed that C# out of the box doesn't have a lines method on strings, which many other languages have. For instance, let's see, I think I pulled it up here. Yeah, Rust has a lines function, which is an iterator, right? It returns an iterator over the lines of a string as string slices. So you have the concept of string slices in Rust, which you don't really have in C#, at least not as explicitly as you do in C#. Anyways, but what it does is it basically it's a in C# you would call that an enumerator. That's the implementation of the iterator pattern in C#. But it iterates on new lines, and you see the characters here. That depends on whether you're basically on a Windows machine or not. And the final line ending is optional. So it works as you would expect, whether there's a new line at the end or not of the string. So how do you do that in C# at the moment? You use split, right? You use split, and you search for those specific characters manually, which is not it's not the end of the world that you have to do that instead of using a lines type of function, but it's nice to have that taken care of, not having to do it manually. So that's basically what we're going to do. At least at first, I was looking at the docs for split, and where did I see? There we go. The split method allocates memory for the returned array object and a string object for each array element. If your application requires optimal performance, which it's a library, right? It's an extension library, so it could be used potentially in something that cares about performance. Or if managing memory allocation is critical in your application, consider using the index of any method, and optionally the compare method to locate a substring within a string. In other words, the performance on this is not great. That's what they're telling us. So we'll probably end up doing a little bit of benchmarking and trying some different ways how to implement this to see if we can get pretty decent performance out of it without hurting usability, right? Ease of use and having a nice API for this. All right, so let's get started. I have the repo here already on my machine. I hope this is big enough for everyone to see. I have increased the zoom. This would be the normal size for me. So let's see how that works. I've already made a branch for this. This is a fork of the extension. So we'll do a pull request when we're done. Hopefully Ardalis, Steve Smith, the owner of the repo, will approve it. All right. Let's see. This is set up basically like a class library. Is your extensions here, and you have some unit tests. And there's a nice little README that basically gives you instructions on how to contribute to the project. Let's see. Extension methods are grouped into folders based on similar purpose. So would probably put that into string manipulation. It's a string related extension. Folder nesting should match class namespaces. Right. Okay. One extension method class per folder. Extension methods classes should have an extensions suffix. So let's go take a look at this. String manipulations extensions. Okay. Classes should be made partial. Static partial class, right? Overload should be placed in the same file. File name should be the contained extension method's name. Replace string. Replace string. String manipulation extensions. Gotcha. Right, because this is a partial class. It's using the same class for each of these extensions, but you want the file name to be basically your extension method name, right? Yes, okay. Test should be provided for each extension method and overload. Test classes should have a test suffix, right? So, okay, pretty common sense stuff. So I guess let's start with the tests. And what I sometimes like to do, let's see. Okay, let's first go in string manipulation. All right, let's just create our file first. I guess it would be called lines. The method's going to be called lines. So lines tests, right? .cs. We need that stuff. Let's just copy it from here. Okay. Public class lines test. Okay. Now let's think about this. What I sometimes like to do is take a look at, let's see, take a look at how other languages, basically what kind of test they use for their implementations of different things, right? So you can look at the, when it's open source anyways, as Rust is, you can look at the compiler source code and see if they have some unit tests in there for their lines function. So let's take a look. I guess we can take a look at the source code. Right. So lines, any lines, here it is. Okay, it returns a, right. So, okay, well, already in the documentation for the function, you kind of have a little bit of a test, I guess. And they're actually iterating through those lines one at a time. I don't know that I want to do that though. Though we could use that for the documentation of our method, the way they are doing it right now. I'll keep that open, but oh, and that's what we're seeing here. Okay, hold on. here's what I'll be going to do. Let's go to GitHub, Rust. Yep. And I think, oh yeah, where is that? Let's go check out library. Test source. No, I don't think that would be it. It's straight up in. Okay, I think it might be in here. Let's do a quick search for lines. Yeah, okay, there we go. I think that Splitator. Sounds like a bad name for some sort of villain in a superhero movie. Splitator. Okay, so there's two tests here. And what are we doing? So we've got the string, which has like, okay, it's got a mix of LF and CRLF, right? Carriage return and like different kinds of ways to signify a new line. So I guess it should work with both. Normally you wouldn't, I think, see in this, like normally strings would either, you know, use one or the other, but the method should work on both. Okay, so there's two test cases. One has, okay, so remember how the method definition, right? The final endings, the final line ending is optional, right? That's basically what they're testing for here. No trailing. And so it's the same data. They're using the same string in both tests. Just one has a line ending and the other one doesn't. But okay, let's start a bit. Okay, let me copy this over. I want to make separate tests for the different kinds of line endings. I think it'll be a bit more a little easier. Let's see. Yeah, let's do it that way. I think that would make sense. Okay, so we're going to call this. Actually, I want to see with VS Code if I try, I think fact. Yep. Oh, there we go. Okay. So what are we doing? We're splitting the string on line endings. Yeah. Let's do with okay, so split string on line ending LF. Let's start with that. And let's just forget about this for now. Pretty simple. Oh, I copied this, right? Okay, there we go. So let's do var. And right, okay, so instead, oh, look at what they did here. Oh, it's a pretty good kind of test case to see if it'll separate things. We basically have two lines here, two line endings, but one is CRLF and the other one is LF. So we'll just remove this. We'll still have the two lines. And so it starts with the line ending. Then we have another line ending, another line ending, then this and that. Right. Okay. So this will be our data. And let's just go back here. Right. It's calling our method. And then it's asserting that we're getting a vector, an array with everything split up properly. This is the termination here. That's our empty line here. That, yeah, okay. All right, so we can do that. I might as well just copy this. We'll just modify it. Because obviously, this is not C#, but Rust. So data.lines, right, which is, okay, this is C#, so it would be like this. And we want collect is not a thing, but so we want this to work with IEnumerable, right? So I think oh, there you go. Code pilot is helping us here to array, right? But obviously, okay, we'll come back to this. All right, so we have our first kind of failure here. So let's start with our implementation. So let's see, string manipulation, add a new file, which we just call lines, because that's the name of the method. And let's just copy whatever namespace we have in the other one. And it needs to be a public static partial, right? Okay. Might not need this, might not need that. I forget this right now. So public static partial class, and it's got to have the name string manipulations, I believe. String manipulation or shins. String manipulation extensions, right? Extensions. There we go. And now we can have our static method, right? Because we're making an extension, if I'm not mistaken. Public static, yeah. Public static. Now, are we returning? We're going to be returning, I guess, an enumerable of string, right? Ooh, look at that. That actually pretty much looks like what we're trying to do here. String text, return text, that's split, new array. I'm guessing you can pass it right. Okay, let's just take whatever they're giving us and walk through this. Okay, this is just missing a using. And this is also just missing a using. Okay. Now let's just go look at our, well, actually, if I just hover, no, okay. There's a bunch of overloads here, and code pilot is using one that passes in an array with two strings, right? So I'm guessing it's going to split on either of those. Just want to make sure this will work the way I think it works. So, yep, that's the one. String split options, string array. Yep. Music keeps stopping. Start it back up. Okay. String split options. So yeah, an array of separators. Strings that delimit the substrings in the string, an empty array that contains no delimiters or null. And kind of options do we have? I think it told us to use none. I just want to see. Default options, remove empty entry line, bit array. contain an empty string from the result. No, we don't want that. We want to have them. Trim entries, trim white space characters from each substring. No, we don't want that. Okay. Right. Okay, so it looks like none is the way to go. And this should work, right? This is the implementation. We're actually going ahead of our tests here because I was just testing this, but it's okay. We can leave that in for now. Yeah, I guess. Okay. So, oh, right. Not contain a definition for to array. Lines returns I enumerable of string. Won't we have to array of that? We did. Let's see. Might be forgetting something here. Data.lines, get enumerator, get hash code, get type. It is probably because I'm not importing what am I missing? It's linQ, isn't it? Link. Why isn't it suggesting it though? Oh, whatever. We'll just do it manually. Ooh, I think my batteries on my headset are running out. Let's see if this works for us now. Yeah, okay, that's what we were missing. So we're to array. So now our lines, yeah, right. It's an array of strings. Let me just swap out the battery on my headset real quick. There we go. Yeah, we're back. Okay. So we've got our array. It's good. It's compiling now, so we can actually assert. How are they doing it? They're basically asserting that. Cool. Would that work for us? Let's see, I'm not that familiar with the assertions being used here. Still relatively new to the wonderful world of C#.net. That two sequences are equivalent using a default compare. That's because of the overload, but okay, so I think it should work pretty much the exact same way. Except in C# I would have to do new string array or something like that. Equals, nope, not equals. I'd replace that with curly braces instead, right? Yeah. It's not complaining anyways. So let's see if that works for us. Doop, doop, doop. Passed 0, failed 1. Uh-oh. And that is because we expected our last... Right. We expected our last line to show up there. And I guess split doesn't... doesn't give it to us. That's interesting. Let's go back and look at our options here. Omit array elements that contain an empty string from the result, which then substrings that consist only of white space characters are also removed. Yeah, we want the opposite of that, right? We want to have the last adjacent delimiters yield an array element that contains an empty string. One of the fields of the string of enumeration specifies whether an element that contains an empty string should be included in the return array. Let's see. Huh. I don't seem to have an option that does what I want, which is to, oh, but that has nothing to do with the options per se. Our problem is that splits a string into substring based on a specified delimiting string and optionally options. Right. So what's happening is when it's seeing that last right. So there's nothing after that, right? It's interesting though that the behavior at the front is fine, right? There's no characters here at the beginning of our string. The first thing we get is a new line, and it correctly understands that it needs to give us an empty string, therefore. But it doesn't do the same thing at the end. Yeah, I guess that's just how split is implemented. All right, let's do a little Google search to see if anyone has so C# split new line. Let's see, split new line, include empty string at end of file, or end of string, I guess I'd say. Easiest way to split a string on new lines. Split a string on new lines. String is method. Let's use C# split new line code. Option to ignore empty parts. We want the opposite of that. How to remove new lines. Test for empty strings and missing values. Okay. Right. This is basically, we have new line. Yeah, I wouldn't want to do that. That wouldn't work with a mix of both. Or if you're trying to read a file that was created on another, let's say you're on a Windows machine, you open up a file that was created on Linux or something like that, and you don't convert the line endings, then this wouldn't work. Anyways, that's not what I'm looking for. I'm looking for how to get our line endings. or string ending. If we have a line ending character at the end of the string, I want to get an empty string. Okay, so everybody's just like saying how to do this. Well, one really kind of naive way of doing this without wasting a ton of time to find a better way if there is would be to, okay, so this returns an enumerator, enumerable, IEnumerable. Okay, so here's what I'm thinking, right? It's too bad because this is nice and clean, but we're gonna complicate this a little bit. We could very easily just do something like var has line ending at end. I don't know. Let's just call it that for now. And then there you go, right? We can do ends with. Oh, but ends with. Do we have an overload that allows for something? No. Okay, well, we can do it that way. That's fine. Ends with that. There we go. That's what I was going for. So, right. So we can do that. Then we'll call this, let's see, lines. And then if we do, if we have line ending, what's it trying to do here? That's because we don't have line queue, so let's do that. Okay. What's it saying here? Take line. Well, we really just want to tack on to lines dot. Yeah, how would we do that? How would we do that? If we want to add something at the end of an existing enumerable without enumerating the whole thing, right? We want this to be lazy. Cat. That's not bad. Does it do what I think it does? Cannot implicitly convert an enumerable string to string array. An explicit conversion exists. Are you missing a cast? Yeah, I don't want to do that. Concat will work on. I think here concat is. Get the. Because there's more, I guess. All right, let me just do a quick search here. So I know there's a way to do this. I just don't know which one. C# add item to end of I enumerable. Can I add an item to an iron collection? Yep. So we've got item. No, that's not what I want. Okay, but whatever. It's like, can we have a method like you cannot, because it does not necessarily represent a collection to which items can be added. That's a good point. What you can do, however, is create a new enumerable, yes, which, when enumerated, will provide all items of the old one plus some. Yeah. Okay. You use. Oh, that's kind of what I was doing. But it will create a new object that will blah 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 blah. Connect feature request. So enumerable methods. System.link here, link. Yes, this would be the one. Example, there's how to use concat to concatenate two sequences. Got an array of this. We've got an array of that. Enumerable cats dot select concat. In a way of concatenate two sequences to construct a collection, for example, an array of sequences, and then apply it to many. Yeah. So this should technically. Oh, that's because we're getting back an actual array and not an enumerable. Right. Right. Okay. So let's switch that over then to well, still, I mean, I think it would be better to have that be instead of straight up the array, although it is the type that we're getting. Not sure what's best here, but let's see. Okay, so, and if we do lines dot concatenate, right, then this works. And then we can just return lines. Okay. Let's run our test. See if that works. Like, I'm not a super fan of what we just did, but I'm pretty sure it's gonna work. Or not. So apparently, oh, wait a minute. Did I get this wrong? Did we? Was it the opposite problem? Let me revert that. Let's see, what did we have? We had yeah, just do undo. It's not that hard to recreate. Or maybe it is. Jeez. I didn't think it was that much. Okay. Let's just do this then. Cut that out. And comment that out. Copy that out. And targets. Right, that's what we had basically. And then let's run our test. Right, and it fails, and we're expecting it to have an empty. Okay, this is where I'm confused, I guess. Because I'm looking at this here. This is our oh, crap. I got the order wrong. That's why. That's why I hate that API. Yeah, expected actual. It is such a... Yeah, so easy to get this wrong. All right, expected and actual. Right, and I guess it was different in Rust, and I just copied it. It was the other way around. And okay, so now if I... so we went down this whole... Let's see. Obviously, it's still not going to pass, but now at least I'll have the correct information, right? So we're expecting not to see that that empty line at the end. And that, I think we can probably fix by changing our option here to... No, we don't want that either. Because if we do that, it's going to remove the empty ones everywhere. Let's just check. Right. See? So we don't want that. That is, there was another one. There was another option, which was trim entries, trim white space characters from each substring in the... No. Okay, so we're still gonna have to do some manual thing here, but at least it should be relatively cleaner because we can just piggyback on... Let's do it like this, right? And then we can simply filter, but in C# it's not called filter, it's called where, right? Nope, that wouldn't work as well because we don't want to get rid of all of them. So how would you just check that the last one, or just trim the last one if it's an empty string. Well, I'm pretty sure where allows us to... Yeah, there's probably an overload in here that gives us the index. String, bool. I don't know what that bool is for. int. That's probably what this is. Yeah, sure it is. So lines, I guess we would need parentheses for this line. Oh, line, it's just one line. And then index, right? And then we can do if but now I'm curious, what's that Boolean? Where do I have this here, I guess? Where I'm just looking at the other ones, but okay, so where take last, take while, then by. Interesting. Where's where? Oh, there. Okay, so source predicate a function to test. Yes, I know. I want to know what that Boolean is. Use where fruit. Okay, so that one's not using it. There's no information on what the Boolean parameters source. Source, right? Because source, then you pass in the and function. That's what I want to know. I want to know what that predicate. What are the parameters being passed into that predicate? Parameters, predicate. Second parameter of function represents the index. Yeah, what's the third one? It's the Boolean, but I don't know what it represents, and I want to know now. Where clause? No, that's not what we want. Well, I don't know. Oh, I forgot. I forgot how these func work in C#. That's actually the return type. That's not the a second parameter. Yeah. Okay. Yep. All right. So then we can do if line.length. No. If how do I do this? The index. I mean, it's great that we're getting the index, but how do we know that it's the last one? We don't we? Yeah, you know what? I'm just gonna do this a bit more with an imperative style. Now I can do lines.last. Which will return a string. Yeah. Oh, the thing though is that we consume the whole. Well, it's okay because it's an array anyways at that point, right? So if lines.last equals an empty string, that's right. Then return lines dot slice. No. Lines dot. Wait, this is not slice. Take, maybe? Takes. What's the equivalent of slice in C sharp? See, that's what it's the fun thing when you're coding in a language that you're not as familiar with. And especially like C sharp, I find for all these like kind of iterator methods has gone with names that are slightly different than what a lot of other languages are using. And I think it's because they tried to make those match SQL. So let's take a look. Yeah, we can get a range. Return a specified range. Yeah, okay, so that would work for us. Surprised though that there's not like a slice, all, any, append, average, cast, chunk, count, distinct, first, group, intersect, join, last, max, min. Range, oh, range might be, oh no, that's not it at all. So it looks like take would work the way we want. So let's use that. Now it's just that we need to pass in either a, oh yeah, we could do count. Sure. We just want to get rid of the last one, right? But that would make it an no, it's like we're making a whole new array, which I guess we kind of have to, but need an else here. Why would you? Yeah, I have a feeling there's a more efficient way to do this. But I guess it's not the end of the world. This would it be like I just hope yeah, I don't think the implementation actually like iterates through the whole thing. Though this well, anyways, let's see if we can at least get our test to pass. Worry about performance later. All right. Okay, so we're in business. Cool. Now our next question is, can we also do that on and now we can bring back our and you know what? Okay, should have made this like a separate test, but I guess that's out of the way now. CRLF, so let's use the data from that other, or actually that's theme one, but I can't remember where the, oh yeah, you know what? I will change all of those to NR, or is it RN? Good. It is RN, right? So RN, I could have just looked at my implementation, yes. So let's switch them all to that format. So here we have two of them like that. And this should work without any changes because we already have that RN in there. Yeah, just do a run all test. Yep, and actually what we could do, let's see, the tests, and we could do .NET run test. There is a way to watch. If we can get some help here. Interactive, no. Let's just try watch and see what happens. Probably like this, I'm guessing. Could not find a project to run. I would have thought that, let's see, tests. Oh, there's another folder, right? Okay, let's try that again. Nothing happens. That's awesome. Well, let's see, .NET run test. Okay, so I guess I'm not doing this right. Maybe .NET test watch. Right, I think that's what it is. Yeah. Okay. There we go. Right, .NET test, and then yes, environment filter, logger, blame crash. No, I don't want blame. Arch. What? There's no watch. I'm sure there is. I've done it before. Okay, to the Googs. C# or .NET test watch CLI. This is everything we were looking at before, and I don't see a watch flag. Are they calling it something different than watch? Oh, is it just .NET watch test or something like that? There's an actual watch command. Okay. Those specified application when changes. Okay. So can I do .NET watch test? Let's try that. Watch test. Or maybe it just, oh, there we go. There we go. Okay. Aha. And we have, right. Okay, so this will actually run all of the tests, but that's fine. Okay, and now let's add final one where split string on line ending with what would you call that? final line ending. Let's do that. With final line ending. Splits string on line ending with final line ending. And we'll actually use now the string that Rust is using in their test, which is a mix of both pipes, LF and CRLF, and also has the end one. Yeah. Okay. And this works, right? Split string on line ending LF without final line ending. That's a mouthful for a test name, but might as well be descriptive, I guess. Oh, oops. Skipped one. There we go. Thing on line ending with final line ending. Okay, so, I mean, we have more unit tests than Rust does. So I think we can feel pretty confident about this working. Okay, so now the question is, how efficient is it, right? Well, first let's do a little commit here since we've got it to work. So implement a lines extension method for string. Okay. Or maybe I could just do something like, which would make it this what it is. Okay. Yeah. All right. Now let's get into the fun stuff. I don't need this here. Like that. Good. All right. I'm gonna keep, I guess I'm gonna keep my unit tests running here. Let's just open a, yeah, I never know where to place my face on these videos. So you can't see the bottom right of the terminal. I'm just gonna open a new terminal, basically. And I'm going to do, okay, let me think here. We've got source, tests. I guess we could add a benchmarks. And what's the convention here? Ardalis.Extensions, Ardalis.Extensions dot unit test, and then he's got, okay, and that's the name of the project. Okay, so let's do that then. Let's add a folder that we're going to call benchmarks. And let's get in there. Oops. And do .NET new benchmarks. Template. Okay, and what are my options here? Oh, I guess I don't, or maybe it's just benchmark. Yep, okay, cool. The name of the benchmark class, don't care about that. The framework, the default is 5.0, might as well make it 6. Add benchmarks config class. No. No restore. No. Console app. Yes. And the default. Okay, so let me just so I can do this. There we go. So we're gonna do .NET. New benchmark. What does it do that? Okay. I guess, okay, I can choose the project. Yeah. Okay, so benchmark framework, right? F, which we want to be net 6.0. Net 0.0. I think it was all together like that. Yeah. And we want console app is true. It's funny, I don't have it in the other options, but let's do console app. Okay, so that should work. And then, okay, then it's just the output, which we are going to call Ardalis.Extensions dot benchmarks, right? Unit tests, benchmarks, and that will be the folder name. And by default, I think .NET New is going to use that as the project name as well. Let's find out. Okay. Guess I could have did a dry run, I think, but restore. Yeah, okay. Ardalis.Extension benchmarks.csproj. Okay, let's go take a look in here. So we've got our csproj here. We just got .NET 6, great. And it's referencing the benchmark.NET packages that we need. It created a program class because it's a CLI, which runs our benchmarks using the benchmark runner. And I guess this is referencing our benchmarks class. Yes, and this is where, okay, this is where we put in our benchmarks. Okay. So we're going to need, maybe do a commit here. Add benchmarking project. Okay. And okay. Will be interesting. All right, well, let's write scenario 1. Let's give that a proper name and call this let's call that naive lines, I guess. Or just like lines, naive. Calling it naive because it's like a simple, just using .NET Split, .NET's own split. So we would be, okay, what would be, so we need, all right, well, so let's be smart about this. We need, what kind of use cases, right, do we have for a lines function? I can think of a few, right? The first one would be, let's say I needed to reach, let's say I needed to reach for a specific line number, right, in a large string, a large piece of text. That would be one. Actually, let me get that down here. So look for a line number, basically, or for a line by line number. I'll do this off screen, but would be one. And another one would be to, well, I get to split to get every line, right? So get every line in a string, which is obvious, right? It's probably the most logical, or not logical, but probable use case for this. And then there's potentially getting, like every n lines in a string. Though I can't readily think of an actual real world practical reason why you would, well, I'm not sure, but somehow it feels like something that we might want to do. Certainly, maybe like in code challenges and things like that. But all right, so I'll put that down as a use case, right? Get every, which I guess is a every n line in a string. So I guess this is the generalization of the get every line in a string, right? Get every line in a string is get every n line in a string with a value of 1 for n. So we can probably get rid of get every line. We'll just have those two use cases, and we can use different parameters for our n. Okay, so let's start with our case where we would want to look for a specific line. No, that's probably not something. Okay, let's do the every n line. That'll be what gives us a better idea for performance anyways too. So how would we do that? Well, we need a string, and now we need like a really big one. Okay. I remember I did that before. Let me go check in my, no. Let's see. Really big text file. I knew it. Looking for large text files for test. Don't forget the collection of corpus. Check that out. Yes. Right. Okay. Collection of information for comparing compression methods. No, we don't really care about that. Compression methods exhibit. So that's pretty big. That's an Excel spreadsheet though. We need a text file. Really big. Oh, there we go. Look at those sizes. That's probably the Bible. Yeah, that's a good. Oh, I think that's actually probably what I used. And this is actual, what's this? E. coli. The complete genome of the E. coli bacterium, but it doesn't feel like that would be very readable text to me. It's the IA fact book, but this is half the size of this one. Yeah, so this is probably the large corpus, right? How do we get this? It's a text file. Is it going to try to just open it? Bible. Oh dear, no. Simple of, how do I download it though? Oh, okay. Zip file. And what did it do? It tried to open it or something? Can I do download, save link, copy link, save link as? Open link in new tab? Maybe? No? Did it put it in my download folder or something? Usually it would show up at the bottom. Oh. No, that's not it. Download. No. Ah, there we go. Weird that it doesn't. Oh, I did download this before. What was I working on today? Let's see. Well, in any case, here it is now. I'll just what's going on? Oh, it is there. Okay. I had. Cool. All right. Let's use the Bible we said we would use. Put that here. Bring that over. Let's just put it in here for now. And there it is, the Bible. How many lines? 30, like upwards of 30,000. That's perfect. And now we're going to, so we need to actually load that into memory, don't we? Get a string out of this. So a bit of IO here. See if I can pull an example of this. So I did that. Here. Did I? Okay. Might have to. Well, okay, so let's just do it in, I guess, a constructor, which marks. Oh, let me see if sure there is a, if I was to go here. Yep. Cool. So okay, and we also need a prop string. Just call it Bible. Do we want it to be public? We don't really care. It's a benchmark thing. I guess let's make it. Public get, then there's only. This doesn't need to be. So Okay, so we need to get our Bible string from the Bible.txt file. Now I think the IO in .NET for the file system is just called file. Yeah, I'm probably missing a using here, of course. If I do file dot, let's see what, okay. Copilot seems to be file read all text. Let me just double check that. I can probably look it up here. File read all. Oh, I'm not. I'm in the CLI thing. Okay. Let's go back here. You know what? String that split. That's right here. File. Ah, there we go. File class. That's the one. Namespace system.io. And methods. Read. Well, there's a. So I guess when you're reading straight from file, there is something that that already takes care of the lines for you. Read all lines, read lines, but this only works with streams, right? But with files, I guess. Yeah, run a string, and that's what we're implementing here. Read all text. That's what we're opens a text file, reads all the text in the file into a string, and then closes the file. Perfect. That's what we want. So simple as that. And then the path. The path, right. If I do this, it will look for it. Oh, you know what? I think I can do. I think here. Isn't there a way? Let me check. I think so. I think using, let's see if Copilot can give us a hand here. Item group. Let's just close that for now. And I think there's a way to say, like, include these asset files in the build. And then they're going to end up in the proper folder. Put optimize, what is it? Oh yeah, okay. I think this will work. So, and this is where we put our file name. But if we do that, yeah, because for that, it's looking in the same folder we're in. And then we need to do, yes, okay, right. New with reserve always. This should work. How I did it, I think in this. Yeah, we'll see if it works. So that would technically I think when we're building it, copy this to the output directory, and in this case, then this should work. The text will be there. Okay. So now we've got that, and then we can just comment. Oh wait, I have to put that in Bible. Right. So every time it creates that test class, it'll read from the file, load that in the string in our property here, and it'll be available for our tests. Okay. And then we actually have to we'll probably do that for us. And I won't know. Maybe we'll see. So if I do Bible dot lines, right? Yeah. Well, it seems to know. How could it though? Ardalis.Extensions benchmarks. How could it see this as? That's interesting. Well, I guess we'll see. So we'll make that function return. Okay, no, there's definitely something weird going because it should be complaining. Ah. All right. Switch that here. Okay, there we go. That's why. Okay, don't want this here. You might need this. Leave it there for now. And okay. I guess that's where it doesn't know where that lines is coming from. And it's not smart enough to. So let's right, because I guess, oh, there is one thing I should be doing. And that is, if I do .NET, then list. Right. Back up. All the way. No, it's one. Yeah, so if I do .NET, then list. Right, so I need to do .NET. Then Ardalis.Extensions dot benchmarks. Right. I have to actually give it the directory benchmarks. There we go. Okay, so now if I do when no, .NET, so list, yeah, it added it. Cool. And now yeah, okay. What was I? Oh, I need to do using Ardalis.Extensions. This. Oh, right. It's because I need to add the package. Right? Yes. Although, let me see here. Don't remember if there's a command line for this. Probably. Let's check. .NET CLI add project to solution. No, add assembly reference, I think is what we would be doing here, because it's our own internal project. So project reference include, and then whatever that csproj is. Let's see how it's done in our test project. That should our extensions. Test is here. Yeah, project reference. There we go. So we pretty much do exactly the same thing, but I guess the CLI would have done that for us if we wanted to use that instead. And we've got that here, let's say. Don't we make that breathe a little? There we go. Okay, so now we should have did I not? Well, obviously I did it right. You would think. This is where I am. These are the tests. Say string manipulation lines. Yeah, this string, yeah. Okay. So probably just need to build or restore or something like that. So let's try that. .NET restore. Mm-hmm. Am I missing using directive or an assembly reference? I was, but I thought I fixed that. Maybe if I kind of force it to reload the OmniSharp server. What if I do, if I just reload the whole thing? Wait till this kicks in. Well, that is interesting. We are not having this problem in unit tests. Right, when I go in here, sees that it's a yeah, right. It's in that other namespace. There we go. That's what I was missing. Let's get back in here. And I guess at that point, after having included the project reference, it would, no, I thought it would, I don't know. But anyways, this works. Okay, so now, obviously, we are returning something, and what we're returning is an array, a string array, which I'm still not like, should I make this an IEnumerable instead? Maybe. Don't know. Doesn't change much, I think, for benchmarking for now. so, right, we've got, what did we say we were going to do? We were going to test, yeah, for n lines, right? Okay, and I know there's a way to add parameters. That's the benchmark thing. Design a benchmark, jobs, columns, exporters, baseline, params. Right, simple as that. So I think we can do that. Where did my music go? There we go. So I guess it's just a matter of having this here. Does it need to be public? Maybe. I guess so. All right, so let's say we're going to try every line. We're going to try every other line. And we're going to try every, I don't know, well, let's make this, let's see, 4, 8, 16, right? This should give us a nice profile. And we're going to be calling this, let's just call it N. All right, so now we would do return Bible dot lines, which is a string. You know what? I am going to make this into an enumerable. Oops. Enumerable of string. And I need. I did not intend to do that. How do I get out of here? Not like that. Not like that. Not like that. What? There we go. Yeah, that's right. Okay. And so now, I guess we will return the same thing. It's not really going to be used by anything, but okay. And let's pretend like, okay, let's see. We're getting our lines and we're going to be, what are we doing? We want to return each n line. So it would be, I guess, would we need a where? And then we can use that index to see. Yeah, that would work, right? Using the modulo. Right. So Bible.lines.where. And I think we need, yeah, okay, there we go. And then we've got the line and index. Oh, there we go. See? Okay, and index modulo and yeah, equals 0. That's exactly it. Right? So if we're doing that, oh, okay, and actually, let's make this an array because if we want to really test the performance, we should realize this, right? We should make this into an actual. All right, so let's see. We're getting n line, and then we're going to get like 1, 2, 4, 8, 6. I kind of want to test that this is working. Let's see. Let's do this instead here for a sec. And just actually, let's do var, just call it benchmark. And call this new benchmarks. And we need n, we need to set n. So let's set, I think this will work, right? Okay. This would give us every line. And then, can I just print that to the console? It's a string. No, it's not a string, it's an array. I don't remember how C# handles this. Let's find out. Console, right line. Obviously, that's not going to work. Benchmark dot lines naive would return an array, and it's going to say you can't print an array because I don't know what to do with this, or maybe not. I don't know what. I have no idea what it's going to print. Like I'm used to JavaScript where you just pass it whatever and pass it an array and it'll print it. I have a feeling it might not be that easy in C#, but I think we're about to find out. So let's run this, and it should be as simple as .NET run. Okay, it's just telling us, thank you. This is a string array. Okay, so how about we, instead, if we have a string array, then we could be doing that toString, right? Maybe? I guess not. Okay. Returns a string that represents the current object. Yeah, so I guess WriteLine does that automatically, right? It takes whatever, and if there's a toString on it, I guess that's what it's showing us. What else do we have here? Well, we could split. Split is something... Or join. No, see? C# has different words, different names for things. Let's go find out. Let's just do a search. C# print array of strings. Really? I have to do that? Join. Yeah, that's what I was trying to do. Oh, I guess it needs that. Oh, it's on string, like on the string system object. But whatever, this will work. I think it should. I don't care having this within brackets. I do want a separator. It's the string representation of an array of objects using a specified separator between each. Yes, thank you. And a new line. That's great. And okay, so now we can do benchmark dot lines naive. Here we go. So technically we should get every line of our Bible printed out now. Yes. Oh boy. This might take a while. That was not a good idea. All right, how about we Control C out of here? But for kicks, let's see if it's faster if we do every 100 lines, or let's say 1,000. There was how many? 30,000. So how about this? We do every 3,000, 30,000. So every, okay, so if we do every 10,000 line, then we'll get 3. Now, let's see. Yeah, cool. It's not easy to see where the line, oh, and it's actually not, let's see if we can do that. It's adding a space. Yeah, it's a space. It's not a new line. So let's do that instead. And then it should be obvious. Right, and I guess I don't really need the comma. Just a new line will do. Okay, and we've got some wrapping here, obviously. But okay, so this 1, 2, and then no, 1, 2, 3, 4. So that's not right unless there is. It's close though. It's real close. Okay, let's check it out. So in the beginning, God created the heaven should be line number 10,000. No, that's not right. That's the first one, right? The Bible starts with that. In the beginning, God created. That would be the very first line. How interesting. Okay, hold on. Yeah, see, this is the very first line. So why is our program returning the very first one? Where line index divided by n equals 0. 1. Oh, it's line 0. Index 0. Right. Well, I mean, in terms of benchmarking, I guess we would be fine. No, and we would want that, right? Because if we did every one line, we want the first line to show it. So you'll always have the first line showing up. That's just, yeah, so that's right. It's okay. I just got this wrong conceptually, but okay. So the first line, then we should get line 10,001 should be the next one, right? 10,001. Eliel and Obed and Jasiel the Mesobite. There we go. Right. Okay. So this works. Just wanted to make sure that it worked the way I thought it did. So we can just forget about all of that now. And cool. So we're ready to benchmark, I think. Let's see. Good lines, where, line, 2 already good. Now, okay, so I guess what we're particularly interested in is, because I mean, just the benchmark in a vacuum like this, not very useful. What we want to know is if there's a better way, better and faster way to do this. Well, right, because remember at the beginning of all this, they did warn us that split was kind of slow. And it was better for us to kind of do our own iteration. So let's do this. Now that we know that, okay, well let's run our benchmark first just to make sure that we've set this up properly. Let's do that. So I guess, and I'm pretty sure we need to run this with release configuration. We don't want this to be in debug. And yeah, so obviously not the ideal way to run a benchmark, right? I'm streaming right now. There's a bunch of stuff open on my machine. If you were really serious about benchmarking, I think what's recommended is that you actually close down everything, including your IDE, like everything, and you just run it from the command line. But, you know, I'm sure we'll get like decent enough results. Because if we can find a way to be like quite a bit more efficient, and we don't care about like nanoseconds in inaccuracies. But if you were like really serious about like really being like just a little bit better, you would want your margin of error from one test, one run to another to be as small as possible. And in that case, you'd make sure that there's as little things as possible running on your machine. But we're not that uh, worried about that for now. So we should get some sort of report with all. Oh, there we go. Oh no, it's not. Okay. And we're running a few versions of that test with our different parameters: 1, 2, 4, 8, and 16. So I guess it'll take a little longer to run because of that. I could have put just like one of the parameters to, but obviously it's running, so it's a good start. Overhead actual, before actual, workload actual, 64 operations in this amount of nanoseconds, which means there's 15.9 milliseconds per operation. And I guess it'll like give us a statistical analysis of all those runs at the end. I haven't configured it though in any way. I just use the template setup, which adds that benchmark attribute. This looks weird. Why was it? I'll fix that later, I guess. Actually, I can do it now. Yeah. Okay. I guess converting it to an array is an IEnumerable, so I could still, right, do this if I want to. Yeah. Doesn't make a difference if we're not really using it, but okay, this is taking longer than maybe we'll cut down on the number of parameters. But let's wait and see what we actually get. Well, I guess meanwhile, what we could do, don't care about that, is go in here and we will, okay, I want to be running my test to make sure. Okay, here we go. Oh, what? That's a weird. Oh, it actually gives it to us per. Is there a way to get this like as a table or something? Oh, there we go. Okay. But that's interesting too. You get the actual histogram. Very nice. Value of the n parameter, mean, error, standard depth. Okay. So we can see that the performance, right, is a little bit better when we're skipping lines. So that's interesting. 17 milliseconds per operation, 14 milliseconds per operation. I think we can get the memory in here too. I'll look into that. But okay, first, let's see if we can get a better version, like a more performant version. But we need to make sure that it also works. So let's call this lines OG, the original one. And we'll make a new implementation that will be called lines so that the tests can run and we can make sure that we're implementing it properly. And we're going to go about this differently. We're not going to be using split. Right? So we could be okay, let's try to do this in a for loop or in a while loop. So I'm just thinking that we should like iterate through the text, looking for our the line ending string. And when we do find it, we take a slice of that string and we return it. So like a substring, right? So I'm pretty sure there's a substring function we could use where we pass in, the start and end index. So we would need to keep a variable of the line. Okay, let's try this. So var line start index, which starts at 0, right? And var line end index, which I guess would start at 0. No, we don't want line end index. We want to keep the current index, right? Keep track of where we are until we hit the line ending string or character. Yeah, how are we going to do that? Because there's one where it's more than one character. Well, okay, let's start with the easy case, which is the LF, just the \n. Where's my music that keeps disappearing? Okay, so we would do, could I use a, whoa. While current index is less than text.length, if text current index equals R. Oh, no, come back. That looked pretty good, actually. Obviously not the first one to do this. Right. So, okay, well, let's just take it. Let's see. All right, so, oh, well, okay, it doesn't pass our test. So we're gonna have to fix something in here. Oh, but that might just be our line tests are expecting. Let me go back here. Enumerable of strings, yeah. Here. Enumerable string. So that's not complaining. That should be working fine. So we're splitting on R. Current index plus 1 is smaller than text.length and text. More confusing trying to figure out what's a. Oh, right. Okay, so first it's checking to see if we're hitting R, then we're checking, is there N right after it? But we're also checking to see, oh, right, because we could have an R at the end of the, you know what? Instead of trying to debug this one, I will just start like I was intending to do. But this is fine, right? We're actually, yeah, we're going until we hit the end of our string. So now if, let's start with the end. So if text current index is, yeah, make it easy. I was going to do that. Okay, so if text subs, okay, so that looks right to me, right? If we do hit N, and return text substring line start index, current index minus line start index. Current in, oh, I guess this takes in the length of the, okay, that's why. I was expecting it to take like an end index, but that works too. Okay, so now we change, since we've just detected the end of a line, we change our line start index, right? To be the current index plus 1. That's exactly right. And we obviously also have to increment our current index. I think we can do that here. Right. Oh, what's interesting to me is that the compiler doesn't prevent us from, or doesn't force us to have like a terminating. Oh, yeah, right. We're into an infinite loop here, aren't we? It would seem. Music. Well, let's see. When we're done iterating through the whole thing. So if we take our case where we have an empty string, let's say, right? We still need to return something, though. Although I don't know how it works with enumerables, if that thing that you necessarily need to. How does it know that it's done? You need to somehow send, I guess when it hits the end of the, oh, well, okay, here's what we do actually, I guess, right? So if we've hit, right, so if we are at the end, if current index is equal text.length, it means we're past it, right? We're past the last one. We I'm pretty sure there must be like, give me everything. Yeah, give me everything, right? So let's say, does that, yeah, start index, and then I'm guessing it takes everything till the end. So, and then we're done, right? So we need to break out of that. Well, I guess we don't need to. It would be, while, no, that doesn't work, because if we're doing is smaller. Oh yeah, it would work because it would happen after we've hit it. Mm. No, that doesn't make sense, right? Because we'll never get to this. So we need to do it. Right. Because it's the index. It's mine. Yeah. Okay. So this would be the last character, right? So when you hit this, return the rest, and then I guess we don't really need to break. Doesn't make sense here. Do that. We're done. We wouldn't be if, yeah, let me see. This should be the end here. And then it would stop the, right. Okay, no, we have to do this here, right? Because otherwise this, yeah, it could twice, could it? Hmm. Okay, at that point, we can just continue, right? We don't want to make that check. Guess we're having some weird problem here. I thought it was stuck in a loop or something, but let's see. Let's try running this again. Total of 1 test files match the specified pattern. That's cool. That doesn't seem right. Is it because then nothing's happening? Right on. Stop that. .NET watch test. That's okay. Let's just try .NET test. Yes, run it, please. All projects are up to date, blah, 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 blah. Total of 1 test files match the specified pattern. which is wrong. There should be more than one. Where am I running this from? The unit tests. Yeah. Forget this for a second. Go in here. Lines test. Okay, I think I might have screwed this up. Yep, I forgot to add the namespace. Would explain. Although it was running before. Okay, try this again. Yeah, there we go. Okay. So if I do this now, it should work. Or not. What if I do .NET clean? .NET test. Or okay, so maybe it is going to some sort of a infinite loop here. No, it shouldn't. It really shouldn't. Current index plus plus. Yield this. And then oh yeah, crap. So I do need to break out of this. Or increment the but obviously they're both fine, I guess. Well, let's do this. It's extra operations, but at the end, it doesn't really matter. So let's go there. Let's try that again. Okay, now this should. What in the world? Okay, let's try this instead. Bring this back. What original implementation? Yeah, okay, so that's obviously what the problem is. Why are we into an infinite loop? If I am, okay, so I use break instead. Would that work? Oh, crap. Yeah. So I also need, right? Because what if we're not at a line? Then it just stays there. Okay, so, which I guess we don't need this then technically, do we? Keep going, keep going, keep going until we're done. But for the last one, we do need to return this and then we break. Which again, okay, I guess we don't need now that we have the current index. This works. Now, the only thing is, if we get to the last one and it happens to be a line index, line ending, we send that, great. But then we get here and it's going to do the same thing, right? So we would need to increment this here, kind of, to kind of make sure that we're not. Well, the other way to do this would be to, make another check for. I prefer doing that. So we do that here. Great. Oh, but then it would happen twice. Okay, so that's continue. There we go. Then I'll just skip all of that. Come back here. It'll see that current index is too high and then escape from the function. Otherwise, we go here. Okay, so I think now this should work. So let's try watch test. Right. Okay, and we expect that two of them fail. The ones with the R's. Actual, right, it took care of the N's, but it didn't take care of the R's. So now we want one that does, all right, if we have an R, and the next one is an N, and it's not the end of the, right, so that makes sense, right? And it's not the end of the line. Then we do this, same thing. Then we, by 2, the current index by 2 as well. And then we continue. I think that's right. Let's see. Yeah. Okay. Okay. That's great. Let's see if we can refactor this though. For instance, this is like our terminating condition. So might make sense to put that at the front instead. Right? So if it's the last one, just give us whatever's left. Cool. So now we don't need to do, because even if it's a new line, it doesn't make a difference, right? Boom, we're done. Does doing yield return will, okay, yeah, so I guess then break. And we're done. Why am I, okay. Break bar. Okay, so in this case here, then we could check if text.current index is n. Great, then continue. If text is r, then do these things and continue. Yeah, and we want to skip doing this check. Like, I was just thinking, can I get rid of that continue? If I do, then it would make this check every time. So no point in that. I guess we don't need this anymore. Oh yeah, we do if it's none of these things, right? If it's none of these things, then just increment the current index and we're in business. But our tests aren't passing, so what are we getting wrong? We are right. We're not. Yeah. We're not taking care of our. Okay, so that makes sense. Let's just keep it the way it was then. Because we have to have the case where we could be ending on a line ending. Okay, so I mean that works. We've got ourselves an implementation that no longer uses split. We're kind of like doing our own substrings. Are we going to get better performance from this? That's what we're about to find out. So now this will be lines OG. And this will be, well, that didn't work. That's interesting. There we go. This will be just lines. Substring. But technically, the implementation should be the same, right? We're still returning an IEnumable. Okay, so let's switch back to benchmarks. Let's get to our benchmark terminal. Lines, substring, returns void, a return keyword must not be followed. Yes, thank you. Okay. I think we're in business. I will stop the watcher on the test. Give computer back that much. Do I have this right? Yeah. And with to array, we're trying all of these. Our lines is now this one, yes. That's the lines OG. Don't this. All right, I feel like I forget something. Oh yeah. Okay, I wanted to add. A way to get memory information. Yes. I think that's what it is. The attribute. Memory die level, let's give it a try and see if it complains. So if I just add can't be that easy, can it? Let me see if I can find an example of this. Unless it needs to be, I think, on the class itself. And not on the two spaces. Yeah, two spaces is what I want. Please. Thank you. Okay, and now it's not complaining. Yeah, okay. All right, let's give it a try. Yep. Okay. What seems to be the problem? Nice naive returns a deferred execution result. You need to either change the method declaration to return a materialized result or consume it on your own. That's interesting though. It wasn't saying that before. But okay, let's just give it a string array. Because we are converting it to an array right here, right? So there we go. Here we go. Fighting. So I'm not sure that we'll actually get a performance increase. Like reading the, where was it? I think it was here. I had it here before. Yeah. So when they're warning us about the performance of using split, they say that the problem is that it allocates memory for the returned array object, fine, and a string object for each array element. I guess that's kind of what we're doing as well, isn't it? Right? No, yeah. See, the difference is, no, I guess it's the same. Now, the difference is that we're not returning an array, right? We are making strings, right? So we are making strings for each of those that we come across. But we're doing this as a generator, right? With those yields. So that means that it will only call, it will only create the substrings that it needs to. I guess we'll see. So my guess, right, my prediction is that for the case where n is 1, it will be pretty much exactly the same thing. But potentially, as we're increasing the number of n, in other words, as we're decreasing the number of lines we're actually interested in, then we might actually have a performance boost. We'll see. I guess we'll see. Yeah, I'm not sure. So the other thing is that we can try doing, right? If you remember the very beginning, I compared or I showed the inspiration for this method, which was Rust's own lines and function. And Rust's lines doesn't return strings, right? It's an iterator, so that's what we did, right? With our function or method being like a generator. It implements IEnumerator or IEnumerable or both, whatever. It's an iterator, but it's an iterator that returns strings. Rust's returns string slices, which are basically just like memory. It doesn't create a new string, right? It's basically a pointer to a slice of a string, of an existing string. So in terms of memory, it doesn't assign nearly as much memory. Probably nothing on the heap, if I'm not sure, but it is more performant for sure. So, and I think C#, it doesn't really have string slices, but it has like that span and memory thing, which is kind of like conceptually similar, I think. So we could try that as well, but that would change our API where we're no longer returning strings, but we're returning something else. Okay, this is done. Let's see. Okay. Oh, that's interesting. We're actually faster even on 1, and we're way faster on smaller. That is interesting. And I didn't expect us to be faster on the case of N1. And okay, and this is, and we're looking at our error here, so statistically we are faster. What about here? Yeah, way faster. Okay. Oh, and it compares the memory allocated. Okay, so we are allocating just a little bit less memory, but it's about the same. So that means that we're we're allocating the same amount of strings or thereabouts. I don't know what the slight difference is. Excuse me. But we are seeing a difference in garbage collection. It looks like our new method, right, is faster, but actually has more garbage collection. If I'm reading this right, hold on. GC generation 0 collects, GC generation 0 collect per 1,000 operations, right? So yeah, we are in all types of garbage collection. Oh, not in everything though. Okay, so for N1, we have a little bit more. For N2, we have a bit less garbage collection of Gen 0, of Gen 1, but then Gen 2 is higher, which I think is fine, because that's really... which one do you want to avoid? I always forget which one's like the worst one. C# garbage collection generations. Okay, the GC algorithm is based on several conditions. The optimize the performance of the to manage help heap is divided into 3 generations, so it can handle long-lived and short-lived objects separately. Yeah. New objects in generation 0. Objects created early in the application's lifetime that survived collections are promoted and stored in generations 1 and 2 because it's faster to compact a portion of managed heap than the entire heap to scheme. This is the youngest generation and contains short-lived objects. An example, generation 1, generation 2. are determined to be unreachable in a future collection. Objects on the large object heap. Right. Okay, so the higher the number, the older the stuff, basically, is what this means. In terms of which one's more performant to garbage collect, I have no idea. But yeah, that makes sense. Oh, that's interesting. As we get to higher ends, we're actually not garbage collecting in Gen 2 anymore. But yeah, we're half the garbage. So all in all, for N1, we're faster, although we garbage collect just a little bit more, but we allocate a little bit less memory. And after that, well, we garbage collect significantly less, and our performance is better. Okay, interesting. Now let's try what I was saying as a third option. And okay, so let's add a benchmark here that we're going to call lines memory. Okay. And I guess we're going to do the exact same thing again. We will start up our tests. We're going to copy this because I think the algorithm will be, it'll be the same. It's just that instead of using substrings, we're going to use memory, or like slices of memory. So this one will be lines. This one will be lines sub. Let's change that. Lines sub. And now this. Okay, so that's the thing like that I'm not a fan of. I think this will be read-only memory of car, right? Because it's a string slice. So I guess the compiler will tell us if I'm wrong. So I need to turn this into, let's call this text memory. Right, I think that's what I want, yeah. Which returns a read-only memory of car, right, okay. And then we can iterate on that. Doesn't really make a difference, so that's fine. Let's go with that. Text current index. Okay, and this is what's going to be different is, oh, now I'm not sure there is an equivalent. Oh, there's got to be. That's the whole purpose of these things, like a slice or something like that. Slice. Yes. See? It's not. Oh, and it's got the same parameters. Cool. So we don't have to change that. So this will be an easy switch. Right? So we're okay. So we're basically making a memory, right? A read-only memory out of the whole string, and then we're taking slices of that read-only memory, which is, from what I understand, is really just like a kind of data structure that keeps like your pointers, you know, like look in memory, this is the start, this is the end, kind of thing, right? And our tests pass, great. No, how can that be? We've changed the API. We're no are yeah. We're not returning. Okay, it's probably because it didn't rebuild or something. Oh no, okay, yeah, it would still work, but the thing is now we're this is incorrect. Our lines are, yeah, it's still seeing it as enumerable ring. Did I not change the right thing? Hold on. Oh yeah, I screwed up. Okay, well, let's make this lines then, and let's make this one. Right, okay, that's more like it. Yes, of course, because now we're not returning strings, we're returning read-only memory of cars. We need to convert that to strings. Is there a convenient two-string? No, that wouldn't make sense because we're in a enumerable. So we would have to do where? No, not where. What's the equivalent of map in C#? Select. Select. And then we have our line, kind of, right? And that we can, our line will be a read-only of car. And if we're lucky, this has a two-string message. And then we convert it to an array, right? So we can do that. So an extra step here for the user, right? So I don't know that I love this. But if we can get, okay, so now we're passing. If we can get significantly better performance, might be worth considering. Benchmarks, yes. I guess I didn't need to do that. I can stop the test. And lines memory, lines stub. Yeah, okay, so I need to do the same thing here. So where line is, okay, and once that is done, I need to select line to string to array, and now we've got our string array. So if we want a fair comparison, I need to make sure that I'm doing this as well, so that we all end up with an array of string at the end. Okay. And let's see. I'm not going to run these, right? Because I already, okay, so I think if I just comment this out, and I think I can add, like, no, benchmark, yes. So I don't know. Yeah, we'll see. Here we go. All right. I think this is the last, you know, optimization I'm going to try. If there is a significant difference, I think I'm probably going to do the pull request with that API, returning read only of cars. And we'll see what Steve says when I do my PR. If he doesn't like it, I can revert back to using the substrings instead. I can probably leave the benchmark in here to show the difference in performance between each method. Yeah. I'm really curious to see. Because now, well, if anything, like I don't know about the performance, but now, if I understand correctly how memory works, and by memory I mean like the memory API, C# memory class or struct, whatever, um, there should be a lot less memory allocated and a lot less garbage collection. And normally that also equates to better performance, normally. So we might get better performance by doing it this way. The question is by how much. If it's just a tiny bit, like I think I'm going to go with returning strings instead, because it's just like more user friendly. It's a better API. We'll see, I guess. Hmm. It's a nice little tool, this .NET benchmark thing. Relatively easy to use. I don't know like how accurate it is and all that, but it seems to be doing some smart stuff, you know. It's always interesting to me when you're talking about benchmarking code in a kind of in the, you know, just-in-time compiler runtime environment. Um, because right, the JIT analyzes your code and will optimize on the fly based on different things. So I guess there's a potential for, you know, optimizations being different in every run depending on, like, I don't know how they're implemented, but it's not like when you have compiled code, like compiled machine code, say like in Rust, where that's the code. That's the code that the machine runs, and it's always that code. Although looking at the margin of error and taking into consideration that I've got a bunch of stuff running on my machine right now, it's not bad. Could be worse, I guess. I've tried benchmarking JavaScript. That's a whole nother thing. It's taking a little longer because we're actually, you know, running several tests, one for each of, well, actually two for each of the parameters for our n. There we go. Okay. Let's take a look. Let's just make sure I didn't screw this up. Line substring, line sub, lines memory lines. And we are indeed using lines for our memory thing. Lines, lines, lines. Yes. Okay. Ah, well, you see, in terms of performance, they're nearly identical. Actually, our memory, as memory, is actually 4% slower in the N1. And they are using, for all intents and purposes, exactly the same amount of memory. And they're doing the same garbage collection. Now, looking at the margin of error, right, this would mean that we can't say for certain that one is faster than the other, right? Because it could be that the actual real mean of line substring is the 13.313 plus 2642, right? And this one could be minus 2754, which would make them overlap. So statistically, we can't be sure, but they're really close. That's what it means. But now here, this is where this gets interesting. It does look like we are using significantly less memory, right? When we are, wow, like a lot. Except for this one. Oh, that is so weird. Oh no, it's just because there's there's an additional decimal here, and this is that's yeah. They should pat this. Funny. Yeah, like we're talking way less memory, and obviously less garbage collection. So that I expected. Oh, so that's interesting. Look at the difference in performance. We're 85, 82%, 74, 72, 74. So it looks like at some point we're not gaining much, like as we're skipping lines, but we are faster with this implementation. That is very interesting. Very, very, very interesting to me. Let me see. I think that the benchmark yeah, artifact results. Yep. Okay, we're actually getting like markdown. Nice. Well, would you look at that? Perfect. Okay, so I can use this. Okay, so let's commit and we'll think about how we're going to present this. Extension benchmarks. Okay, so what? How is it already in the .ignore? Oh yeah, we should look at that. Oh no, that's not it. Nope. Oh yeah. So I guess by default it's already in the git ignore. Which it's fine. I can probably copy this into the PR or something. Okay. So how do I want to do this? What are we going to do? I'm going to make my PR with, okay. I don't want to leave these in the actual source code. Let's start by moving these to our benchmark class, I guess. Let's move them here at the bottom. Wait, yeah, no, here. Okay, port this system, line OG, and line sub. Okay, and then we can call this, that's the benchmark. That's, I guess these can be private. And now I can call this lines, call this one split. And this one's going to be line sub. can bring that back here. We'll make this the baseline. And let's see if we can maybe remove one so that it's a little faster to run. We'll make these the params now. Okay, so now this, we'll call this lines split. And it's going to be using lines split. Right, it needs to be, it is static, isn't it? But it needs to be public, I think. No? I thought. And no accessible extension method. Line split accepting at first arc. So this is an extension method. Why wouldn't it work? Does it need to be on a different? Okay, extension method must be defined in a non-generic static class. Yeah, I forgot about that. My bad. Okay. So we will do that. And so the question is, where do I put these? Do I want them to be... Oh, crap. I think I screwed up here. Oh, I don't need this. I could put them in... I want to... I could put them at the bottom here. I don't know what he's going to think about this, but yeah, for now, let's do that. Public. Or actually, let's make this protected. Partial, no, what is it? In package? No. Public, partial, protected. No, there's forget. Let's just do class. How's that? We're gonna call this benchmarks string extensions. Let's just copy these in here. Oh, it needs to be a static, we said. Okay, now that, okay, great, that works. Apparently we don't need this. Fine. This works for us. in lines split, lines substring, lines memory. Yes. Okay. Running this, that's fine. Just double check. Got the memory slice thing. Right, okay. Benchmarks here, our tests were still passing. Let's just make sure. Watching. Great. Last thing that I would do is add some documentation, and I think I can probably let's move this here for now. Let's move it to the side. Okay. And let's see. Nicely. Yep. That's the good thing. About lines. Where is it? Well, I just lost it. That's interesting. It was right there. String, method, lines, and it's nowhere to be found. What, did they just remove the... Oh, there we go. Lines. Very weird. Okay. But still, I don't see it in here. Oh, here it is. It's because it's in dref. Okay. Cool. Yeah, I was just saying that. Anyways. Okay. Getting a little tired. I guess it's time to wrap this up. Okay. So let's just run the benchmark again while we're finishing up this thing here. Because I want to use the results of this in my pull Well, I've got two baselines apparently. That is true. The line split to be the one. Okay, so we have our documentation. It's fine, that's fine, that's fine. I think we're good. Let's just run the benchmark. But actually, first, let's do commit, add benchmarks for, well, we did more than that, didn't we? Optimize. String with benchmarking. Like that. And now we should be able to run this. Yep. Okay, good. It's doing its thing. And while that is happening, we can start working on our pull request. Lines, yes, that's the one. Compare pull requests. Can't automatically merge. Yeah, that's fine. That lines into main, yes. Let's say add a lines string extension method. Okay. Let's see. I've decided to make this method return a read-only, no, memory, read-only memory, read-only. How does it go? Yep. Read-only memory car. Actually, it's an enumerable car. Yes, that is correct. Instead of in enumerable of ring because there is a significant, well, let's say a non-negligible performance gain in doing so. I've compared doing 3 different ways of splitting a string on new lines. Here are the benchmarks. And since this is, let's see, it should give us markdown output, as we've determined. Okay, not done yet. Anything else we need to add in there? Not really. Well, I could say, okay, this method is inspired by Rust's dot lines method. Okay. I guess the fact that we're not converting to a string for every line inside of that method, of that extension method, can be a significant performance increase, because you can imagine someone using that function to get access to every line, but needing, just one line. Like I was saying, one potential use case is like trying to find line number 30,263, so in that case, the user really only needs one string for that line. And with using memory like this, um, that's what happens, right? We really only get one new string for that one particular line that we're looking for. Interesting. Okay, here we go. Let's go get our results. I can copy all of that straight into my pull request. And it should be, wow. Isn't that beautiful? Perfect. Yep, that's exactly what I wanted. Great. So I think I can create my pull request. Let's just take a look at the actual changes here. Files, down here. Adding this. That's all stuff for this project. And we're adding our benchmark file and our extensions here. Oh, it's actually, yeah, I guess it would. Okay. And here's our actual string manipulation extension. Yeah, Texas memory, do all of this, do all of that. Great. String manipulation, lines test. Good. Okay. I think we can create that pull request and call it a day. It's past noon. I'm starving and I need to go to the washroom. All right. Oh, yeah, that's fine. Deal with that later. Cool. Good. That's it for me. Ta-ta.